And then it's up to you, but I would suggest take a break dun sa week, and then maybe you can start reading habang napunta kayo sa cemetery. Para tawag dito, maano nyo uli yung momentum. Kasi minsan pag sumobra yung break, baka hindi na kayanang bumawi. Okay? Baka pagpunta nyo sa libingan, naiwan sa libingan yung motivation nyo. Okay? So, at the end of the module, this is the thing that you need to learn. No, but teka lang. There you go. Okay, so you have to define the energy and enumerate the different forms. So I think in my recorded slide, you have a definition there of energy. Okay. At yung different form niya. And then you have to write that thermochemical equation. You have to differentiate exothermic and endothermic, and then you describe the first and the second law of thermodynamics and assess their impacts on the problem, then describe the Gibbs free energy and predict spontaneity using thermodynamic quantities, and then describe the change of state, the energy changes that accompany them, and interpret phase diagram. So most of them are not included in the lecture core. If you're going to look at the phase diagram, it was in the lecture that contains the solid and liquid thing. Okay, but what I'll try to do here today is to give you some sort of the summary of everything that you need to know here without the calculation. And then when we come back, the first meeting that we have, which would be Thursday in 2 weeks, right? So we're going to go everything in detail, but I still want you to work on your own, okay? Doon sa tinatawag nating recorded lecture natin. Okay? Nahanap ko yung notes ko. Okay. So if we're going to look at the main thing here, we're talking about energy. So energy is what? The capacity to do.
Capacity to move matter.
Okay. To move matter, to do work. Okay. And there are a lot of what we call energy. So meron kayong radiant, meron kayong thermal, okay. Meron kayong chemical, meron kayong electrical, nuclear, and so on. Okay. And included dito sa energy changes, especially that involves chemical reactions, are what we call the heat and temperature. Now, the meaning of them are not what we call the same. Okay, heat is the transfer of thermal energy, usually from warm bodies to cold bodies. So you only have heat transfer where there is temperature differences. The temperature is a measure of thermal energy. So we could say heat is what? Thermal energy, but temperature is a measure of thermal energy. So temperature is not equals to thermal energy. Okay, so if we're going to look at the notes that we have, I'm trying to use it with the notes that you have. So when we're talking about thermodynamics, it deals with energy changes. Okay, and usually if we're talking about thermodynamics, it's answer the question, will the reaction happen? And if the answer is yes, the next question is how fast is the given reaction? So that's thermodynamics. And one branch of thermodynamics is thermochemistry. So thermochemistry is just thermodynamics that deals with chemical system. Okay? Now, usually, if we're going to look at the energy, ano yung unit niya? So the SI unit that we have for energy is usually joules. But the one that is commonly used is what? Ano yung common unit na ginagamit pag energy?
Calorie.
Okay? Calorie. So joules ang SI unit, pero calorie yung common term na ginagamit as what we call unit of energy. Okay? Now, whenever we look at this thermodynamics, we always involve what we call three systems. Okay? Teka, meron yata akong PowerPoint dito. Why I'm not, yun na lang gamitin ko. Napakahirap tayo. I have a PowerPoint slide, so yun na lang yung aanohin natin para at least. Makita nyo. Okay, yeah. So this is about thermochemistry, thermodynamics. Okay, so as I have told you, energy is the ability to do work. So kita nyo, or the capacity to do work. So you can have radiant energy, thermal energy, chemical energy, nuclear energy, and potential energy. Okay, so all of them is the different form of energy. Now, if we're going to look at these energy changes in a chemical reaction, we have this term heat, okay, versus the so-called temperature. So when we're talking about heat, this is just the transfer of thermal energy between two bodies that are at different temperatures. And it's usually, it's from what? Warm object to cold object. That's why you call it heat, right? Because if it's from cold object to warm object, anong tawag mo dun? Coldness? Di ba ganun yung ginagawa natin kapag hindi welcome yung dumating na tao? We give the person the cold treatment. Walang warm energy. You see now the connection in real life, right? So maybe my mistake, I showed you the exam results right away. So ang dating ngayon ng lecture natin ay cold sa inyo, right? Okay, so that's heat. So temperature is a measure of the thermal energy. So try to look at this way, yung difference nila. You have 1 gram versus 1 kilogram. So if you want to raise the heat by 1 degree, or if you want to raise the temperature by 1 degree, do you have the same heat? Will you use the same heat for 1 gram as the one in 1 kilogram? Yes or no?
Same amount, sir. Yes po.
One
Yes,
gram and 1 kilogram versus 1 kilogram, you're going to use the same amount of heat?
As a basic po, sir, kumbaga 1:1 po.
No, 1 gram versus 1 kilogram. So let's say 1 gram of water versus 1 kilogram of water. Are you going to apply the same amount of heat to raise the temperature by 1 degree?
No, sir.
No.
It must be higher.
So doon yung difference ng heat at temperature. So you're going to
Yes,
have the same temperature, but the amount of heat you apply is different. Okay,
Yes,
because thermal energy is not temperature. Temperature is just a measure of thermal energy. I'm just trying to distinguish here the heat from temperature. Now, when we're talking about thermochemistry, as I told you, it is part of thermodynamics. So thermochemistry deals with what? Chemical reaction. Chemistry is just about chemical reaction. Chemical reaction is the heart of chemistry. So if you're going to look at thermochemistry, those are the heat that is involved in chemical reaction. And usually we have what we call the system, okay, which is the specific part of the universe that is of interest in the study. So it can have an open system where both the matter and the energy can exchange. It can have, you can have what we call a closed system where only energy is the one that can be exchanged, or you can have what we call an isolated system where nothing happens or nothing is being exchanged. So what's an example of isolated system? That's unique to the Filipino.
The thermos.
The thermos.
The thermos.
Or the what we call the Dewar plus. Okay. So what happened is the Dewar plus or the thermos, it will maintain the heat. Yun yung nilalagay ninyo ng kape or chocolate or ano man mainit na tubig. After sometimes mainit pa rin. Okay. Now, another thing that you need to know is the so-called exothermic and endothermic process. So what's the difference between the two? So you just look at the word X. So when you're talking about X, that's just what? Exit.
Expel, except.
Okay. So you could just say exit. The energy exit from the system. Okay. And when you have endothermic, the energy enter the system. And if you're going to look at this, the energy is in the product side if you have an exothermic reaction, and the energy is in the reactant side when you have this endothermic reaction. Okay, so that's one thing that you're going to what we could need to know. And if you have the so-called why. I cannot write. I don't know why. So another way to do it is when you have the so-called delta H. So when you're given an exothermic reaction, your delta H is a negative sign. If you're given an endothermic reaction, your delta H is a positive sign. So that's another way of knowing what we call the difference between an endo and an exothermic reaction. Okay. And if you're going to look at the schematic of this, what we call exothermic and endothermic reaction, so usually exothermic, giving of energy, the energy level of it, okay, is higher at the beginning compared to the final condition. So the energy was released. So from a high energy at the reactant side, okay, the energy level is reduced, what we call, due to the release of energy to the surrounding. Okay. Now, this is different from the endothermic reaction. So initially, the energy level of the reactant is lower. Okay, and when the energy is absorbed by the system, okay, the energy level becomes higher. So what is the possible question that you're given here? Which of the following is an exothermic process? Which of the following is an endothermic process?
Okay.
Okay, so those are the possible questions that will be asked. And if you're going to look at thermodynamics, this is just a scientific study of the interconversion of heat into other kinds of energy. And maybe it might not be included doon sa module natin. We have the so-called state functions, properties that are determined by the state of the system regardless of how that condition was achieved. So energy is a state function. So when you look at the energy, it doesn't care how you get to the present stage. Okay, as long, okay, as you go to the present stage. So whether you took this path or this took this path, it doesn't care if it's a state function. And if you have a state function, here, the potential energy of hiker 1 and hiker 2 are what we call the same. You're just looking at the difference where they came from and the height. That's the potential energy. That makes it a state function. It doesn't look at the path. Or you could say, oh, the other one took a longer path. Nope. Now, the example that I always have in my class is whether you come from Staten Island, Long Island, whether you come by biking or by swimming, as long as the time that we have in class, you're there in my class. Okay? Now, the thing that you need to know about the state function, energy is an example, pressure is an example, volume is an example, and temperature is an example. So all of them, okay, depends on the initial and the final condition. And the difference between the final and the initial conditions, that's the, what we call property that you're looking for. Now, one thing about this thermodynamics, you always have this different law of thermodynamics. So we have the so-called first law of thermodynamics, where energy can be transformed from one form to another, and it cannot be created nor destroyed. So ibig sabihin, the exchange of energy is just between the system and the surrounding. So whatever is released by the system, it is absorbed by the surrounding. Or whatever is absorbed by the system, it came from the surrounding. Okay, so like this one. So this is what? An exothermic reaction. Okay, so what happened if you have this exothermic reaction? You lost the chemical energy by combustion. So that's the system. Okay, and the energy is gained by the surrounding. So combustion is an exothermic process. So ano yung kailangan yung alamin? There are other forms of what we call the first law of thermodynamics. So you can also look at it in terms of this. Energy is equals to Q, which is heat, plus W, which is work. Okay. So if you're going to define work, work is equals to what? Force times distance, right? So if you're sitting the whole day, strictly, you are not working because there's no distance involved. Okay, so the delta E that you have there, that's the internal energy of the system. So the internal energy is equals to Q, that is being exchanged between the system and the surrounding, and the Q can be what? Positive or negative. Work is the work done on or by the system. So work is usually the negative pressure times change in the volume. So there's involvement with the gas expansion against a constant external pressure. And the thing that you need to remember here, this sign. I'm going to post this PowerPoint in your group chat, okay? In our group chat. So that's how work is involved in this discussion. Okay, so we have discussed already the system and the surrounding. Okay, and if you combine the system and the surrounding, what do you have?
The universe.
Okay, you have U and I, which is the universe, right? Tama ba? U and I. Okay, so that is what we call the universe. That's where you have what we call the system. So that's your the one that you want to study, and anything around it is the surrounding. And you combine everything, that's you and I. That's the universe. Okay. So what else do you need to know? If we follow, I just try to what we could look at the module. So we have this what we call the enthalpy and the first law of thermodynamics. So if we're going to look at the enthalpy, so this is the work that is done by the system. So if you're going to look at it, okay, so as you could see, if there's expansion, the delta T is equals to what? A positive. Then if you multiply it with the negative P, so you will have there a work. So work is not a state function. Okay. Now I don't want to do calculation as of now because I want you to have a what we call the good rest, and then we will go back with this after we come back. So I just try to what we call go on the thing. So the enthalpy that we have, if we're going to look at this, it is discussed in my recorded lecture. So if you're going to look at the enthalpy, that's just your delta Q. Okay. So if you're going to replace that internal energy, your Q there, that can be your enthalpy, and the W, that's pressure, okay, times delta B. And if you're going to look at that, rearranging that one, delta H is just the internal energy plus work. Okay, so enthalpy is just used to quantify the heat flow into or out of a system in a process that occurs at constant pressure. And your enthalpy is your delta H. Okay, so what do you need to know here? The delta H that is positive, that means it's endothermic. The delta H that is negative, that means it is exothermic. Okay, so that's what we call the enthalpy and the first law of thermodynamics. So if you're going to look at your module, do you even read the module? Do you answer the questions that you have here? So if you have the sign here, so what's endothermic? Anyone?
Positive po.
So this is positive, this is negative. So here heat is what? Absorb, and this one
Absorb.
Yes.
release. So for the endothermic, the surrounding gets cold. Okay, for exothermic, the surrounding gets hot. Okay, but tayo doon?
Yes, sir. Yes,
Okay.
sir.
So for
Yes, sir.
endo, heat is part of the reactant. For exo, heat is part of the product. And then the energy of the products is in endothermic higher. Okay. Then the reactant. For exothermic, the energy of the product is lower. than the reactant. So I want you to, usually ito yung minimum yung sagutin nyo yung mga question dyan. Yung lecture talaga is just additional discussion. So if you're going to look at the video, maybe some of the topic there are not included. So you just look at the one that has the topic that you have here. Like Hess law. What do we have here in the Hess law? So Hess law, when we summarize or add the different reaction, okay, the total enthalpy is just equals to the sum of all the reactions that involve. That's what Hess law means. Okay, regardless of the numbers of a reaction, the total enthalpy for the reaction is just the sum of the enthalpy changes of the different steps. And then I just try to what we could do this thing, but we will go back to this entropy. What is entropy? Anyone? Is a degree of what? Disorderliness, right? The word is usually what? In chaos, right? Kaya sa Miss Universe, anong usual question doon? Anong gusto mo mangyari sa mundo? World peace. Right? Kasi mahirap magkaroon ng order. Because if you leave a system on its own, okay, chaos will happen. And the more chaotic or the more disorder it is, the higher is the entropy. That's what entropy means. Okay. And the second law of thermodynamics, I think the statement that they have there is the entropy of the universe is increasing. So entropy is just a measure of disorder or randomness. And the way that you're going to look at this, if the delta S is positive, it's more disordered. If the delta S is negative, it is more ordered. Which is more disordered, solid or liquid?
Disordered. Liquid, sir.
Okay. So whenever you dissolve, or we could say melt something, the degree of disorderliness increases. Because you can have a question here, which has a positive delta S, which has a positive or negative delta S. So if you have a positive delta S, usually you have spontaneous forward reaction. Ordered state to disordered state. Spontaneity has nothing to do with entropy. That's another, what we call physical quantity. Okay? Because what they're trying to do, okay, can we say if a given reaction is spontaneous? Can we say if it's not spontaneous? So what did they observe? Delta H, some positive happens spontaneously. Some negative delta H, like combustion, happen spontaneously also. Okay? So delta H is not enough to say whether the reaction is spontaneous or not. But what they found out, whenever they have a spontaneous reaction, your delta S always increase. Okay? So the combination of H and delta S gives you delta G. And delta G has something to do with whether the reaction is spontaneous or not. What is a spontaneous reaction? Anyone? I-ano lang natin to, tapos bakasyon na kayo. Spontaneous reaction is any reaction that happens on its own, right? It's a process that happens on its own. Now, I have an statement. True or false? Failing an exam is a spontaneous reaction. Sige nga. Teka, asan na yung ating poll? Relaunch poll. So yes or no lang ang sagutin nyo. Failing an exam is a spontaneous reaction. Ignore the what we call exam results there. Failing an exam is a spontaneous reaction. Sige nga. True or false? Or yes or no? Failing an exam is a spontaneous reaction.
Yes, sir.
Hindi, gusto ko makita yung result.
Okay.
Yung walang sasagot. Tingnan natin paano mag-isip mga taga-UP. Failing an exam is a spontaneous reaction. Yes, it's true. No, it's false. Sige nga, only 18 answered so far. Asa na yung iba? Natutulog? Asa yung 10? Failing an exam is a spontaneous reaction. Asa na yung ano? 4 pa. Ba, dikit ang laban. Bakit may bahala si Batman? It's either yes or no. Okay?
Dadasal para sa universe na pumasa, sir.
Sasagutin natin yan. Failing an exam is a spontaneous reaction. True or false? Okay. Kaya kayo bumabagsak sa exam eh. It's true. Bakit?
Kaya yung pinagugutan natin ng lakas, sir.
Pag wala kang ginawa, spontaneously, you fail. Gets nyo?
Yes po.
Ito yung result. So not all of you believe that failing an exam is a spontaneous reaction. Remember, spontaneous reaction or spontaneous process happens on its own. Kung nag-aral ka, it doesn't happen on its own. Naglalagay ka ng effort. Okay? Naglalagay ka ng motivation. Pag will ni God na bumagsak, babagsak talaga. Pag wala kang ginawa, talagang babagsak ka. Yun lang yung masasabi ko sa iyo. It's a spontaneous process. Okay? And as I've told you, ito, anuhin nyo to. Knowing how they construct exam, they always ask a question like this. If this is positive, this is negative, ano yung delta G? So ito yung granddaddy equation na tinatawag ko. And you can look at this lecture doon sa chapter 18. Kaya wala to dito sa handout na meron ako eh. Kaya nagdumiretso na ako dito. Okay? So if you have a delta G that is negative, that means it's spontaneous. And whenever a reaction is spontaneous in the forward direction, it is non-spontaneous in the backward reaction. Okay? Now, phase changes. So what causes the phase changes? Usually the energy. You increase the energy, you have phase changes. You decrease the energy, you have phase changes. So what do you need to know? You need to know kung ano yung iba't ibang process. So if we're going to look at this, the way I usually discuss this, in case hindi nyo napansin, so usually, so when you have solid, oops, no. Ayan, wala. So if you're going to look at what we call the phase changes that we have, so all you need to do is put solid, liquid, gas. The holy trinity of physical state. The Son, the Lord, and the Ghost. Okay? So if you're going to look at this, solid to liquid, you have melting. Liquid to solid, you have what? Anyone? Ano yung process from liquid to solid?
Frozen.
Process. Freezing.
Freezing. Freezing.
Yeah. Hindi ko pala na share. Okay? And if you have what we call liquid to gas, ano yun?
Evaporation.
Okay, so usually it's vaporization.
Vapor.
And then if it's the other way around, it's condensation.
Condensation.
And sometimes you go to solid without passing the liquid state. What do you call that? Sublimation.
Sublimation.
Okay. And if it's the other way around, you call it deposition. Okay. Now, any heat involved here, like melting, that's what we call the heat of fusion. Liquid to gas, that's the heat of vaporization. Now, if you use Hess law, you add these two, what do you get? If you use Hess law. If you watch the lecture of mine, it's there. That is the heat of
Sublimation.
sublimation. Pareho lang yan sila. Because what happened? You have, let's say, water solid going to water liquid. So you have a delta H of fusion there. And then you have H2O liquid going to H2O gas. You have what we call the heat of vaporization there. So what will happen to the reaction? You cancel this. So you end up with this one. Right? And the thing that you have there, heat of sublimation, that is just the sum of these two. That's Hess law. Okay? Ano pa yung next na kailangang i-ano doon? Is it the phase diagram? So the supercooled liquid and the supercooled, superheated liquid. Or we could say the heating curve and the cooling curve. So when we have the heating curve, this is just like this. So what do you have in the heating curve? So here you could put heat and that's temperature. And what happened when you apply heat? So you have a solid here, okay? And when it starts to have here, what will happen here? That becomes solid and liquid interaction. And then all the solids are melt. So the liquid, it starts to have liquid, the temperature goes up. And then here you have the liquid to gas. And then you have what we call all the liquid are evaporated, all of you have gas. That's your heating curve. Now the cooling curve is the reverse. You're removing energy. Okay, and as you remove energy, the temperature drops. Now sometimes you have what we call the super cooled or a superheated liquid. So the superheated liquid, okay, this one already what we call goes up, but it's still in the liquid phase. Or the super cool, this one goes down, but it's still in the liquid phase. Now, the phase diagram on the other hand, so these are all in chapter 11 of my lecture. So you have there what? A temperature and pressure. So here you can have what? This is the solid phase, the liquid phase, and the gas phase. So what does it mean? As the pressure decreases, okay, you become more solid. As the temperature increases, you become liquid and then gas. So you can find here this one where the three physical state exists as what you call the triple what? Point. And at 1 atmosphere, what can you say? So this is your boiling point. No, not boiling point. That's your melting point. And this one is your boiling point. Yun yung summary no ano natin, yung module. So what I want you to do, okay, you take a break and then we will come back with this one. So ito yung mga phase diagram na inano ko sa inyo. So that's the summary of everything in this module. And the coverage, I think, of the second exam is module 4 and module 5. And it is on November 16, right? Or November 18.
Hindi ba module 3 to 5, sir?
Module, no, hindi kasama ang 3.
Sige po. Salamat po.
It's just module 4 and 5. So question. That's it for today. So magbakasyon kayo. Okay? And then by All Saints Day, ano yun yan, na uli kayo, ano nyo na yung momentum nyo. You gather your momentum and then start studying module 3 and 4. Prepare for the exam. Sana i-off the record ko.